All right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still doing our understanding VIT or Visual Transformers module, which we actually finished up this morning. So let's have a look at what we went over today. Now, like I suspected, the visual transform or the understanding of visual transformers was just a note-taking module. All we did was take notes and go over demonstrations and presentations. So we're gonna pick up with some light reading and then move on from here. So at the very beginning of small data, the transformer model finds it difficult to make much sense out of the patches, but as soon as we increase the data set to considerable amounts, the transformer model now, free of the inductive bias, can do even better than the confidence. And interesting enough, we'll notice that after training a transformer model, the position embeddings we call, which are added onto the patch embeddings before passing it to the transformer, actually learn on their own to encode the position of the patches. We can also visualize what the model sees by looking at the attention maps. You will notice that after training the model, we have the attention maps, which are pixels, which pay more attention to one another as compared to other pixels, which will be pixels from the input. So we have two sets of pixels. One set of pixels coming from the attention map patches, and the other set of pixels coming from the actual raw original inputs. Now, the raw original input pixels, again, will be way too many for our model to handle. Well, it wouldn't be too many for our model to handle, but it'll be overwhelming. That's why we're breaking the image up into patches to begin with and using attention maps to focus on those particular patches so we can feed smaller sizes of data to our model for easier handling. Now, in summary, to understand or to visualize what goes on when training the CNN and VIT model side by side, we'll see that the VITs, as we increase the data size, or rather when we start with small data sets, we have less accuracy than the CNN model. While for the CNNs, we already have reasonable accuracies even with small data sets. So out of the box with small data sets, it seems like the CNN will perform better compared to the VIT. But as we keep increasing the data set, we see the accuracy of the VIT model increasing, while for the CNNs, at some point, plateauing starts to happen. Now, basically, that's what we went over with this entire module. We were just going over different concepts and new understandings of visual transformers, how they work, how they operate, how to implement, and how to navigate around them. So this was an all notes module. So what we're going to do is we've finally done this one. We can start our next module, which is going to be actual coding, as I'm assuming not compared, but as I'm assuming because of the name of the actual module is going to be building bits from scratch. So in this section, we'll be going over the process of building bits from scratch. So yeah, like I said, we're finally out of the note-taking module. We can finally get back to coding and doing exciting things. Well, it was exciting taking notes also and learning new things. So I'm not going to say that it wasn't, but I'm glad to get back to the coding aspect of things. And of course, I will keep you posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.